Good morning, good evening, and good night, depending on in which time we are going to observe this lecture. In this lecture, we are going to discuss a very important thing on the states of matter chapter. So far, in the 11 lectures, we have discussed about different aspect of the state of matter, that is the gaseous state. We have discussed many things. The gaseous law we have discussed about the Dalton law of partial pressures, then Graham's law of diffusions. Then we have discussed the ideal gas law, real gas equations, that is the Van der Waals equations, and also the last video we have discussed about the Joule-Thomson effect. So in this lecture we are going to discuss something different topic, that is in this chapter, the state of matter chapter, that is the liquid state. So in this lecture we are going to discuss the liquid state. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Liquid state. How do you define this very important state of the matter? How do you define it? We know physically the liquid, that is the another state of the matter, but how do you define it? Basically, liquid can be considered in continuation of the gaseous phase into a very small volume and having the very high attractive forces involved in it, that you can easily able to understand when the molecules, when the gas has been compressed to a minimum level, and at that time what is going to happen, the distance between the molecules in the gas is so small that it will be attracted by each other with a very high attractive forces, and that there will be a transformation of the state of the matter, that is in the liquid state. And you can consider liquid as a state which is in between the gas and the solid. So in the liquid state, what is going to happen? The intermolecular distance is so less, that is, has been found the intermolecular distance in case of liquid, you can see intermolecular distance. Intermolecular distance is normally, it is ranging from 10 to the power minus 5 centimeter to 10 to the power minus 7 centimeter, and it is so less that molecules almost touches each other. There is a very little gap, and that is why there is a highly attractive force, intermolecular attractive force has been there, and that is going to create the very important characteristics of this state of matter, that is liquid. It is having the higher density than the gas, and as because of intermolecular force of attraction is very high, the molecules are being attached to each other very tightly, and that is why what is going to happen, the molecule could not able to be separate out from each other. That we have observed in case of gas, the molecule is free, but in this case molecule will not be able to separate out from each other, and that is why the liquid has a specific volume and definite volume in like your solid. And at the same time, although it is been attached very tightly and it could not be able to separate out from each other, but the molecules can be separate out from each other. the molecule can be slipped from each other. That is, this is the molecules that this you can visualize this. This is the molecules. The molecules position will not be changed. Suppose this is one of the molecules, set of molecules. So these molecules will not change, but these molecule can slip past from each other. These molecules, these can be able to slip past. So what is going to happen? Liquid have a special property, that is the flowing property. It can flow like a fluid. It has a property of fluidity, and that is why when we can keep this liquid in some container, it will take the shape of the container. That is why liquid do not have any shape. So this very two important property, that is already we know that liquid has a specific volume, but they do not have any shape. So that is the two things. And another very important physical characteristics of the liquid that we are going to understand in this lecture, that is, number one, we will understand the vapor pressure. Second, we will going to understand the surface tension. And third, we are going to discuss the viscosity. These are three very important physical characteristics of the liquid. First, let us understand the vapor pressure. When we fill some liquid, that is not fully, partially, in some evacuated container, what is going to happen? The portion of the liquid will evaporate to the remaining volume of the container, and this evaporated, that we will call it is a vapor, and it will exert a pressure on the vessel surface, and this is called the vapor pressure. And initially vapor pressure will be very low, and after that it will goes on increasing, and it will comes to a level where we find the vapor pressure will be almost constant. At that time we will call this vapor pressure as the equilibrium vapor pressure, or we call it a saturated vapor pressure. What is going to happen in this process? Let us understand. If we take this, if we want to graphically represent this phenomena of vaporization, we are putting here, this is the time in the y-axis, the rate of evaporation. The rate of evaporation you will find for a particular temperature, it is a constant. We can write evaporation. And another thing, that is the rate of condensation. This rate of condensation, as we go on, it will goes on increasing, and the time will come at the equilibrium point. This is the equilibrium. Equilibrium point, what is going to happen? Both this rate of evaporation and rate of condensation will be equal. And at that time, the vapor pressure is called the saturated vapor pressure or equilibrium vapor pressure. And this is depend on the temperature. At a particular temperature, evaporation will be always constant from the liquid surface. Why it is so? Let us understand. This is because this is governed by the Boltzmann factor. Boltzmann factor says, another thing we want to understand, Boltzmann factor. Boltzmann factor says this is the Boltzmann factor. E is your energy. It says that at a particular temperature, the portion of the molecules, fraction of the molecules will have the energy that will be given by this factor. The portion, the fraction of the molecules having the energy E is given by this factor, and you can see this is only depend on the temperature. So higher will be the temperature, higher will be the number of the molecules that will be evaporated, because there will be all the when the evaporation started. Suppose this is a container. In this container that you keep the liquid, and here evaporation only will continue from this by the molecules which on the surface, and at the same time all the molecules will not going to be evaporated. Those molecules will be going to evaporated which is having this E, particular E value, and this is governed by this factor, that is the Boltzmann factor, and this is the, you can see in this factor only a factor is there, that is a temperature, and that is why at the particular temperature the rate of evaporation is constant, and with the time the condensation will goes on increase. At the equilibrium you will find the rate of condensation is equal to the rate of evaporation, and this evaporation depends on various factors that we are going to understand. Factors of rate of evaporation. That is depend on two factors. Number one, that is the nature of liquid, and this evaporation you will find that is different for the different liquids. It is not same. Suppose we give the diethyl ether. Suppose we have taken very common liquids, diethyl ether, then we have taken the carbon tetrachloride, CCl4, then we have taken the alcohol, then we have taken the H2. The vapor pressure will be different for these liquids, because here if we try to arrange it in order of increasing the vapor pressure, what we will find? Diethyl ether having the highest vapor pressure, followed by CCl4, followed by C2H5OH, followed by H2. Why it is so? And that is because of the one factor, that is the intermolecular force of attraction. The liquid which having the higher intermolecular force of attraction, its vapor pressure will be lower. As for example, you can see H2O here, intermolecular force of attraction is very high, because there is a hydrogen bonding. That in the hydrogen bonding we have observed that one H2 molecule has been attached to the 4 H2 molecules. So there is a very high intermolecular force of attraction in terms of your hydrogen bonding, and so what we find that is vapor pressure will be very less. And as you can see here, but diethyl ether, the intermolecular force of attraction is very less. That is why you can see its vapor pressure will be higher as compared to the other things. So what is there? Thing is that the nature of the liquids going to impact on this vapor pressure during evaporation. And second thing, that is already I discussed, the temperature. Higher the temperature, higher will be the vapor pressure. At that time what is going to happen? This given heat is utilized to break the bonds, break the intermolecular forces, and liquids will be easily evaporated. So evaporation, there is two factors, and what is evaporation and what is vapor pressure, that we have already discussed. Now if we want to define the vapor pressure, what will be the definition? Definition for the vapor pressure is, suppose we want in the exam, you have been given a question, define it, what you write? You will write, it is the pressure is basically it is the pressure exerted by the vapor present in the liquid surface with the container vessel with the container which is in equilibrium with the liquids. Because during the time there is a two phase you can find, one is the vapor phase and another is the liquid phase, and between these there will be the equilibrium. So we understand what is evaporations, what is vapor pressure out of the evaporation that we discussed. Boiling, we are now going to boiling. What is boiling? Let us understand. When we are going to, suppose this is a container, in this container liquid is there and we are putting some heat. So what is going to happen? Initially there will be the evaporation from the surface, right? Evaporation we will not say, we will call the vaporization. We call this is a vaporization. Vaporization from the surface of the liquid. But as this temperature is increasing, when the vapor pressure of the liquid, this is a very important thing that we need to understand. Vapor pressure of liquid. Vapor pressure of liquid is equal to the external pressure. Because we are heating this vessel which is open air, which is open, there is no cover on the up. So vapor pressure of the liquid when is equal to the external pressure, at that time the vaporization will start from whole of the liquids. It is not only the surface, it is throughout the liquids you will find, and this type of condition we will call the boiling. When the vapor pressure of the liquid and the external pressure that is equal, at that time what is going to happen? The liquids will be vaporizes from bulk, from all the liquids that it will going to be vaporizes. At that time we will call this is a boiling. So we can say boiling is a condition. This is a condition when the vapor pressure of the liquids is equal to the external pressure on the liquids. So at that time we will call it is a boiling. And at 1 atmospheric pressure, the temperature in which liquid boil is called the natural normal NTP, normal boiling temperature. You can say normal boiling temperature. So at 1 atmosphere pressure we will call it the normal boiling temperature and its value is 100 degree Celsius. And at 1 bar pressure At 1 bar pressure, the temperature is called the standard boiling temperature. Standard boiling temperature. This temperature will be less than, will be 99.6 degree temperature. 99. So at this temperature, at 1 bar pressure, the standard boiling temperature is 99.6, and at the normal temperature 106. So we can have this boiling points for some liquids also. You can make a graph also. So you can see it should be having the 349 Kelvin and it is having 353 Kelvin approximately, and it is 273. So from this graph you can able to understand the boiling temperature is different for different liquids. Now we are going to discuss another very important property, that is the surface tension. The well-known fact that liquid take the shape of the container, but there is some phenomena like a drop of mercury forms a spherical bead. It will form a spherical bead instead of spreading on the surface. Or there is a rise or fall of liquids when in a very thin capillary, when it is come in contact with a liquid. So this type of phenomena cannot be, it is in contradictory of this fact that liquid or it takes the shape of the container where it is kept. This can be explained with a very unique property of the liquids, that is the surface tension. And how the surface tension of the liquid occur, let us understand. It is basically the tendency of the liquid, you can write it, it is the tendency of the liquid to keep the surface area minimum, and that is the point, that is the thing from where it starts to show the surface tension. It always wants to keep its surface minimum. Why? This is because of this fact you can understand that liquid and molecules at the surface of the liquid, here this is a molecular surface of the liquid, it will always be experience a net inward force, attractive force, net inward attractive force. And when there will be the force that you can easily understand, there will be a pull or tension in the surface, and that is why the energy is higher. It is always to keep the as minimum energy, as minimum molecules as possible in this surface. So that only can be achieved by minimizing the surface area. So you understand how the liquid have the surface tension, because it has a tendency to keep the surface area as minimum as possible. And when we call the liquid is at a minimum energy state, when we call now at that time when its surface area is minimum, and that is happen in case of a drop of mercury. Drop of mercury, instead of spreading, if we spread, then what is going to happen? That is surface energy, it will not able to satisfy this condition, that it will always wants to keep its surface energy as a minimum. That is not able to possible. For that, what will going to create, what will going to make? Now it will make its surface area as minimum as possible, and that only can be achieved when it will be in a spherical bead shape, and that is why we will find a small drop of mercury forms a spherical bead instead of being separated, instead of being spreading in the surface. And that is why, that is the main thing that we need to understand why surface tension is there. That is, it is a tendency of the liquid to keep the surface area minimum, because at the surface the molecules will experience a inward force, because at the upper there is no molecules, it will only be pulled it. But if we see the bulk, molecule at the bulk, it will be attracted all around, it will be attracted from all around, so there is no net force. So energy of these molecules at the bulk of the liquid is very less as compared to the energy of the upper surface of the liquid. Energy of the molecules at the upper surface, that will be very much higher as compared to this. And to minimize, every system wants to make its energy at the minimum level, and that is why it wants to minimize its surface area, and this is the case of the surface tension of this. And in this way, due to the surface tension only, you can, when put in a capillary, thin capillary in a liquid, it will rises, and that is the thing, that surface tension is there. Now, how to define the surface tension? Let us understand. Surface tension, as we understand, it is a force. Surface tension, it is a force. And this force, you can understand, it is being acting perpendicular to the surface of the liquid. So we can write it, it is a force. It is a force per unit length, per 1 centimeter you can say, or you can say 1 meter. It is a force per 1 centimeter, 1 meter, perpendicular to the line drawn to the surface of the liquid. Surface of liquid. So you can easily understand what is this. This is a force basically. This you can see is a force, inward force. This force has been attributed as a surface tension, and you can have this measurement of the surface tension is force per 1 centimeter or 1 meter, that is perpendicular to the line drawn to the surface of the liquid, and its units, what will be units? These units of the surface tension will be Newton per meter, or you can say that will be dynes per centimeter. So Newton per meter by dynes per centimeter, that will be the units. Units of this is Newton per meter by dynes per centimeter. Now another thing comes, that is the surface energy in relation to the surface pressure. Surface energy. So we understand one very important thing, that surface liquids want to minimize the surface. So if we want to increase the surface, what we have to do? We have to do some work against the attractive forces of the molecules. So we can write, it is the energy, surface energy is, it is the energy required to extend or increase per square centimeter or square meter along the surface. So we can write the surface energy is basically this. So surface energy, we can write this formula: surface energy will be the work done. See, basically work done per square centimeter or per square meter. So work done is given by this work done, that is Newton. Work done, that per centimeter, you can see that is the work, that is force into distance. So force, what is force? That is Newton is the force and distance is meter and it is square meter. So we can get its unit is Newton per meter. So you can see this unit and this unit is totally same. And what are the factors for the surface tension? There is a main factor that you can usually understand. It is basically the attractive forces between the molecules, and the higher the attractive forces, higher will be the surface tension. And naturally, those factors which is going to influence the intermolecular force of attraction, that is the temperature. At the critical temperature, the surface tension is 0. At critical temperature, the surface tension is 0. So we understand what is surface tension and what is the units of the surface tension and how their surface energy is correlated to the surface tension, that we understand. That is all for today's lecture. In this lecture, we have discussed the very important characteristics of the liquid, that is the vapor pressure and the surface tension. In the next lecture, we will going to discuss another very important property of the liquid, that is viscosity. And I hope you understand all the points that I have tried to mention here. And if you do not if you have any questions, you can comment in the comment sections. And if you like this lecture, you can share to your friends. And that's all for today's lecture. Okay, thank you.